Okay, this is lesson 5.3, Understanding Angles. An angle is formed when a ray is rotated about a fixed point called the vertex. What's a ray? A ray has an end point and it continues. So we're taking this ray, designated right here, all the way across to my arrow. This is our ray, and if you rotate it around a vertex, you create an angle. Where the ray starts is called the initial. And where the ray stops is called the terminal. So this is the initial arm, and that's the terminal arm. This starting spot is also called the initial position. So we'll call this the start. This is where the angle starts being created or is initiated, and this is where the terminal or the angle stops or terminates. We'll call it the end. You can also graph this on a Cartesian plane, and that's called an angle from standard position, and I'll show you. The vertex of the angle is the origin, and the initial arm lies along the positive x-axis. And its terminal arm can lie in any of the four quadrants. Or on any of the coordinate axes, so it can end on the axes as well. So what's this look like? Well, here is my initial arm starting in standard position. This is the standard starting position. And we're going to have it rotate into the first quadrant and create an angle. There's my angle. There's my vertex. Now, if we rotate it into the first quadrant, we're rotating and creating an angle somewhere between 0 and 90 degrees. So our starting point, or our initial arm, if we don't rotate, that would be 0 degrees. If we were to rotate all the way to the positive y-axis, we'd be creating a perfect right angle, and that would be 90 degrees. If we had rotated all the way into the second quadrant and down onto the negative x-arm, that would have created an angle of 180 degrees. If we kept rotating all the way around to the negative y-arm, we would have hit 270 degrees. And if we did one complete rotation all the way around the Cartesian plane, we'd end up right back at the start, and we would have traveled 360 degrees. So the way an angle looks on the Cartesian plane is it falls somewhere on or between 0 and 360 degrees. Unless we keep rotating around and around and around, we could end up somewhere bigger or smaller. Not smaller, bigger. And we'll look at those later in the lesson. Now notice every time I drew an angle, I rotated in the same direction. And that's because if we're creating an angle that's positive, it's formed by a counterclockwise rotation. Of the terminal arm. And a negative angle is actually formed by a clockwise rotation. So what do I mean by that? Well, let's draw a positive and a negative angle. If I've got my initial arm, I'm going to draw it on there to bold it for the first couple times. There's my initial arm. And let's rotate into the second quadrant this time. I'm going to rotate this arm into the second quadrant. And notice I'm not doing this precisely with a protractor, I'm just estimating. And these diagrams are great for estimating and drawing. Let's say that I went 130 degrees. I went more than 90, less than 180, and as long as it's reasonable to say a number between 90 and 80, or 180, let's say 130, then this diagram could very well represent that angle. And since I went in the positive direction, I rotated 130 degrees. Let's rotate backwards. and I'm going to draw on negative 130. To do that, I would start at my initial arm, and I would rotate clockwise, this time going into the third quadrant. And let's say I went exactly the same distance into this quadrant as I went into this quadrant. Well, then I would have traveled 130 degrees in the opposite direction, which we represent as negative 130. So depending on which way we rotate, you can create positive and negative angles. Another piece of terminology that we need to be familiar with is something called a coterminal angle. Coterminal angles are angles that share the same initial arm and the same terminal arm. So let's show a couple of those. I'll go back and start with my 130 degrees. Here's my angle. It's in the second quadrant. How could I draw another angle and end up in that same spot? Well, I could rotate backwards. I could start at the same initial arm. I could have the exact same terminal arm, but rotate in this direction. And how would I find out what that angle is? Well, I could do a little bit of math. And that little bit of math says if I rotated 130 degrees into the second quadrant, 50 more degrees would have got me to this arm. 50 more degrees would have got me to this arm. And that little angle has a name too, and we'll talk about that later. So if it's this exact same terminal arm, that means that this little angle in here again must be 50 degrees. Since I rotated backwards, I rotated 180 degrees backwards and 50 more backwards. Well, 180 plus 50 is 230. So that angle backwards would have been negative 230 degrees. And I call this theta 1, and I call this theta 2. Considering they are different angles, even though they are coterminal, means they end up in the same spot. What math could I do to get from here to here? Well, if I started here, if I rotated all the way backwards, I would end up right back here. A backwards rotation is negative 360 degrees. So the math to go from 130 to negative 230 would have been 130 subtract 360. And that would have given me my negative 230 degrees. Let's try another coterminal arm. I'll start same initial. I'm going to terminate right here. This time what's going to happen is I'm going to start at my initial arm, and I'm not going to stop at that terminal arm right away. I'm going to rotate past it. In fact, I'm going to rotate all the way around the circle and then stop at the terminal arm. And this creates another coterminal angle. What angle? Well, it's still the 130 degrees here to here, but there's a whole other rotation added on top of it. So if I wanted to figure out what my third coterminal angle would be, it would be 130 degrees plus a full rotation of 360 degrees, which would be 390 degrees. Bet you might have already thought of another way to get another coterminal angle. Well, it would just be to go around again. Do 2 rotations before ending up at that same terminal spot. But I'm going to show you another one that maybe you didn't think of. Same terminal arm, but we're going to rotate backwards this time. Instead of stopping there on the first pass, we're going to go through it, and we're going to end up there on a second pass. And how do I find that? Well, the first time we went backwards and ended up, it was minus 230. And if I go around one whole more rotation, that'd be another 360 degrees in the negative direction. So my fourth angle would be negative 230, which was the first time we went backwards and ended up there, and we would subtract another 360 because we're going another full rotation, and that would be minus 590 degrees. So all of these angles, 130, negative 230, 390, and negative 590 are coterminal angles. And I want to show you the math that I've done to get those. I started with 130, I subtracted 360. I started with 130, I added 360. I started with a different coterminal angle, minus 230, and I subtracted 360. Basically, to get a coterminal angle, find the angle from standard position that's positive the first time it hits that arm, and then either add or subtract 360 degrees. And that will get you another coterminal angle. All right, let's flip it over. Principal angle. The principal angle is the angle between 0 and 360 degrees The coterminal angles 480, 840, and negative 240 all share the same principal angle of 120 degrees. It's the first positive angle less 360. So 120 would be a principal angle, and if we added 360, we get 480. If we add 360 again, we get 840. If we subtracted 360 from 120, we get negative 240. All of these four angles are coterminal, just like the four angles we found on the last page. So we're going to determine the principal angle, 150, and we're going to find a positive and a negative angle that's coterminal with it. I changed it from 510. So let's start by graphing the 150 degrees. That would put us in the second quadrant because we're greater than 90 but less than 180. There's my 150. My first coterminal angle would just be rotating backwards to get there. Right there. And to find that, I'm just subtracting 360. Because I'm going here and then I'm rotating backwards a full 360 to end up in the same spot. And if I subtract 360, I get negative 210 degrees. So the first negative angle would just be subtract 360. Okay. The first positive angle would be from adding 360. So to graph that, I would start here, I would rotate all the way around, and I would end up back at the same spot. And to find that angle, I would take my 150 and I would add a full rotation of 360. And that would give me 510 degrees. And again, I just added 360. So let's try to square away this terminology. Principal angle is an angle between 0 and 360. If you're given a principal angle, like 150, to find the coterminal angles, we would add 360 and subtract 360. What if you're not given a principal angle? Like the next example, I'm given negative 55 degrees. Well, I'm going to start you off. We're going to find the principal angle, and then I want you to find the coterminal angle. Okay? Let's graph negative 55. Negative 55 degrees would be backwards, and it would be less than negative 90, so it would be in the fourth quadrant. Now, since that angle is not between 0 and 360, we'd have to find the related angle that is between 0 and 360. And that would be from standard position around in the positive direction. So our first theta would be 360 degrees would be a full rotation, but we're short by 55. So that would be like adding 360. which would be 305. And there's our principal angle, 350 degrees. And how did we get it? Since it was negative 55, we just added 360 to get our coterminal angle. And our coterminal angle was the principal angle, which means that negative 55 is a coterminal angle. I want you to try to find the first positive coterminal angle. And you can find it by starting with your principal angle and then adding 360. So the math would suggest that that would be 665 degrees. I want you to draw it on the Cartesian plane. And be sure to check the answers on the website. Last piece of terminology is a reference angle, sometimes called a related acute angle. So what is a reference angle? Well, a reference angle is formed by the terminal arm of an angle in standard position and the x-axis. Remember before when I said that little angle I drew on the last page had a name? Well, its name is reference angle or related acute angle. It's always positive and will always lie between 0 and 90 degrees. It will be a acute angle, 0 and 90 degrees. So if I draw, I got four angles here, 50, 128, 265, and 340, we can find the related acute angle. So let's try 50 degrees first. Graph 50 degrees. That would be an angle in the first quadrant. That's my theta. Theta is 50 degrees. I should probably label that on there. Theta. Theta means principal angle. My principal angle is 50 degrees. What's my related acute angle? Well, it says the related acute angle is always formed from the terminal arm and the x-axis. Well, here's my terminal arm, and here's the x-axis. That angle right there between terminal and x-axis is the related acute angle. So in this case, an angle in the first quadrant, or an angle between 0 and 90, the principal angle is the related acute angle. And that might seem a little confusing, but it's okay. It can have two names. Principal and related acute angle in this case are the same thing. And the reason they're the same thing is because the related acute angle has to be an angle between 0 and 90. And if I was drawing from the terminal arm to this x-axis, that'd be creating an angle bigger than 90. So it couldn't be a reference angle. Let's try 128. If I graph 128 from standard position, I end up in the second quadrant. So how would I find my related acute angle? Or where is the related acute angle? Well, it's between the terminal arm and the x-axis. Here's my x-axis, here's my terminal arm. The reference angle is right there. So that's beta. Question is, what is it? Well, when you have an angle in the, I'm going to label it, second quadrant, the way you find beta is beta for reference angle. You take 180 degrees and you subtract the principal angle. So, how would we do that? Well, we do 100, I'll do the math over here. Beta would be 180 degrees minus 128 degrees. Basically, that's how short this angle is from getting to the x-axis, which would have been 180 degrees. It fell up, in this case, 52 degrees short, which makes our reference angle 52 degrees. What if we rotate into the third quadrant? Well, this says 265. 265 is bigger than 180, so it's more than rotating to here, but less than rotating to this arm, which would be another 90, 270. So I'm going to write on 180, 270. So that means 265 would be like right here. There's my 265. So where's my reference angle? Well, my reference angle, or my related acute angle, would be right here. And we're in the third quadrant. So how do I find a reference angle in the third quadrant? Well, If I had rotated all the way to here, that'd be 270 degrees. So to find my related acute angle, I fall up a little bit short. Sorry, I don't fall up a little bit short. I fall up a little bit short of 270 degrees, but I've gone past 180 degrees. How far past 180 degrees did I go? Well, you can do a little bit of math. Beta would be theta minus 180 degrees. If we take off this part of the rotation, we would end up with how much extra we've rotated. And if we do that, 265 minus 180, we end up with 85 degrees. And that's about as big as beta can get. There's my 85 degrees. It can be all the way to 90, but in this case, 85 degrees. That would be our beta. 265 would have taken us all the way to the terminal arm. 180 would have taken us all the way to the x-axis. The difference is 85 degrees. That's our beta. And last one. 340. 340 would put us into the fourth quadrant. So there's my theta. So how do I find beta? Well, in the fourth quadrant, we would fall up a little short of rotating 360 degrees. So how much short? Well, take the principal angle that you have and subtract it from 360. Beta would be 360 minus theta. That would tell us how much is left over to fill in the beta. So let's do some math. Beta would be 360 minus 340, which is 20 degrees. So what's this mean? Well, what it means is a principal angle can be drawn from standard position from the initial arm, counterclockwise, into any of the four quadrants. Whichever quadrant you draw it into, you can also find a related acute angle, beta. The way you find your related acute angle varies depending on what quadrant you're in. If you're in the first quadrant, it would be equal to the principal angle. If you're in the second quadrant, you would have to subtract your principal angle from 180 degrees to find your related acute. If you're in the third quadrant, you'd have to subtract 180 from the principal angle to find the related acute. And if you're in the fourth quadrant, you'd have to subtract the principal angle from 360 degrees. As you get more comfortable working around the Cartesian plane, these aren't things that you're going to have to memorize. You're not going to have to memorize the rules for each of the quadrants. It will become logical to you to figure out a beta based on an angle from standard position. Basically, the beta and the theta end up either adding or subtracting to 0 or 180 or 360, and it depends in which quadrant you're drawing. As we practice more and as you work with your practice questions specifically for this lesson, that's going to become easier and easier for you. That's it for lesson 5.3. Thanks for watching, and I'll see you next time.